Understanding multiplication in terms of scaling and rotation. Example 1. To take away 5. This means we rotate 5 by 180 degrees. We see that we get negative 5. Example 2. To take away negative 4. To take away means to rotate by 180 degrees. So when we do this, we get 4. In other words, to take away 4 negatives would be to make something more positive by 4. Example 3. Two groups of 3 means that the 3 is scaled by a factor of 2, so it becomes twice as large. The answer is 6. Example 4. 1/2 of 6. The scale factor is a half, so 6 is reduced to half its size. The answer is 3. This example illustrates why it is more accurate to understand multiplication in terms of scaling rather than in terms of repeated addition. Example 5. 2 times negative 3. This means the negative 3 is scaled by a factor of 2, so it becomes negative 6. Example 6. Negative 2 times 3. This is the same as taking away 2 groups of 3. Here we have both scaling and rotating. The scale factor is 2, so it is enlarged by a factor of 2, and the negative or minus sign means that we rotate by 180 degrees. This gives us negative 6. Example 7. Negative 2 times negative 3. This is the same as taking away 2 groups of negative 3. We see this question also has scaling and rotating. The 2 is the scale factor, so the negative 3 is enlarged by a factor of 2, and the minus or negative in front of the 2 means we rotate by 180 degrees. We see the answer is positive 6. When we multiply 2 negative numbers, we get a positive answer. In other words, if you take away 2 groups of negative 3, you would make something more positive by 6. Now let us look at how this idea of scaling and rotating applies to indices or powers of numbers. Example 8. Negative 2 all to the power of 3. This means that negative 2 is multiplied by itself 3 times. The negative 2 is scaled and rotated twice. Negative 2 scaled and rotated once gives us positive 4, and positive 4 scaled and rotated again gives us negative 8. There is a more complex way to approach this or understand this relating to complex numbers on the Leaving Cert course. Negative 2 has a modulus or a size of 2. It has an argument of 180 degrees. In other words, it points in the negative direction of the real number line. If you multiply the moduli, 2 by 2 by 2 gives us 8. This is the same size as our answer, negative 8. And if we add up the arguments, we see we get 540 degrees, which is also pointing in the negative direction of the real number line, giving us a negative number 8. In other words, when we multiply numbers, we multiply the moduli and add the arguments. We might also notice the size of our answer is 2 to the power of 3, which is 8, and the argument of the answer is 3 times 180 degrees, 3 times the original argument. And here we have de Moivre's theorem. To raise a number to a power, the modulus is raised to that power, and the argument is multiplied by the power. So de Moivre's theorem is about scaling and rotation. Now let us apply some of these ideas of scaling and rotating to complex numbers that have both imaginary and real parts. Here we have an Argand diagram showing us the complex plane. The imaginary unit, iota or I, stands for the square root of negative 1. What happens when you multiply a number by I? We notice that 1 multiplied by I gives us I multiplied by I, or I squared, gives us negative 1. Negative 1 multiplied by I gives us negative I. So multiplying by I seems to be the same as a rotation of 90 degrees. When you multiply by I squared, which is the same as -1, it is a rotation of 180 degrees, which is consistent with what we've been saying. Example 9. If z is 1 plus 2i, show iz on the Argand diagram. Well, I times z means we rotate z by 90 degrees. This gives us -2 plus I. Example 10. Here we have an Argand diagram showing us the position of z. On the same Argand diagram, can you show the position of 2z and zi? 2z means that z is scaled by a factor of 2. Z multiplied by I means that z is rotated by 90 degrees. Example 11. This Argand diagram shows us the position of z. We are asked to show the position of a half I squared z on the same Argand diagram. But I squared is -1, so half I squared z is the same as minus a half z. This involves scaling and rotating. First, we will scale it by a factor of a half. And then we rotate it by 180 degrees. Check out projectmaths.ie for more helpful teaching and learning resources.